Hello students, you are watching ICSE Mathematics and we are solving chapter number 7 Ratio and Proportion, ICSE Mathematics Standard 10. We are solving exercise 7B and in that the last question which we solved was first of question number 12. Okay, before we solve the second question of question number 12, let me solve one question which was left over as it is not in the textbook, it is not included in the old textbook, it is in the new textbook. So let me complete that one question. Okay, let us start. According in new textbook, it is question number 10. Okay, so let us solve question number 10. Okay, it is given that the numbers k plus 3, number k plus 3, k plus 2, 3k minus 7 and 2k minus 3 are in proportion. We are given that numbers k plus 3, then k plus 2, then we have 3k minus 7 and 2k minus 3 are in proportion. These numbers are in proportion. Okay, and therefore we know that if A, B, C and D, four numbers are in proportion, then we can write A is to B is equal to C is to D, and therefore we can write over here K plus 3 is to K plus 2 as 3K minus 7 is to 2K minus 3. Okay, now we know the rule that product of extremes is equal to product of means. Okay, and therefore product of extremes, that is k plus 3 into 2k minus 3 is equals to, we have k plus 2 into 3k minus 7. Now let us multiply and simplify. Therefore we have 2k square minus 3k plus 6k will be 3k only, minus 3 3s are 9 is equals to 3k square minus 7 plus 6 minus k minus 14. Let us transpose all the terms on the right hand side, on the left side. So therefore 2k square minus 3k square plus 3k plus k minus 9 plus 14 is equal to 0. Therefore minus k square plus 4k plus 5 is equal to 0. Taking minus 1 common, equation is k square minus 4k minus 5 is equal to 0. Now we can factorize this quadratic equation. We have to find two factors of 5 such that the difference is 4. So two factors are 5 ones are 5, 5 and 1. So we have k square minus 5k plus k minus 5 is equal to 0. Now we can take common. K we can take common from the first term. Therefore k can be taken common, k minus 5, and plus 1 can be taken common. Again we have k minus 5 is equal to 0. Therefore we have k plus 1 into k minus 5 is equal to 0. Therefore k plus 1 is equal to 0. or k minus pi is equal to 0. Therefore, k is equals to minus 1 or k is equal to 5. So we have obtained the two values of k. Here, one is minus 1 and the other one is 5. Okay, so the 10th question is over. Now let us start question number 12 onwards. In the new textbook, it is question number 13. Okay, first one we have already solved. Now let us solve second one. Question number 12. Second one. Okay, a square plus b square is to c square plus d square. We have to prove a square plus b square is to c square plus d square is equal to AB plus AD minus BC, AB plus AD minus BC into other bracket CD minus AD plus BC. Okay. Okay, let us recall that we had taken that two ratios were given. A is to be 4 numbers A, B, C, D are in proportion. So A by B is equals to C by D is equals to K we had taken, and therefore A is equals to BK and C is equals to DK. So we have values for A and C. Let us take LHS and substitute the values. Okay, LHS is A square plus B square is 2. We can write upon C square plus D square. Okay, now for A we will put BK. So we have BK the whole square plus B square upon for C we can put DK. So DK the whole square plus D square. Okay, which is equal to B square K square plus B square upon D square K square plus D square. Take B square common from the numerator. We have K square plus 1 and D square common. Again we have K square plus 1. So we can reduce this brackets K square plus 1, and therefore we got B square upon D square, which is equals to B square is to D square. Okay, now this is the LHS. Now let us simplify RHS. Now we will take right hand side. Okay, what is right hand side? The right hand side is AB plus AD minus BC. AB plus AD minus BC into CD minus AD plus BC. Okay, now let us substitute the values. Value of A is BK and value of C is DK. Okay, is equals to, okay, for A we can put BK into B plus BK into D minus B, and value of C is DK upon C is DK into D minus AD. AD is BK into D plus B into DK. Okay, let us simplify. So bk into b square k, we have b square k plus bkd will get cancelled. Yes or no? This we can reduce. Similarly in the denominator also. So we are left with b square k upon d square k. So we can further reduce this k. So we have b square upon d square, which is equal to b square is to d square, and which is equal to right hand side. Clear? So we have completed second of question number 12. Now let us solve the third one. Okay, a square plus ac plus c square. We have a square plus ac plus c square is to a square minus ac plus c square, a square minus ac plus c square is equal to b square plus bd plus d square is to b square minus bd plus d square. Okay, so let us take left hand side. LHS is a square plus ac plus c square upon we have a square minus ac plus c square. Okay, value of a is bk, so bk the whole square plus bk into value of c is dk plus we have dk the whole square. Again the same values, bk the whole square minus bk into dk plus dk the whole square. Okay, so let us simplify. So we have b square k square minus bd into k square plus we have d square k square. In the denominator we have again b square k square. Okay, numerator we have plus in the middle term, yes or no? Okay, so b square k square minus bd into k square plus d square k square. Okay, now we can take common k square from both numerator and denominator. So we are left with b square plus bd plus d square upon again from the denominator k square common, so b square minus bd plus d square. So we can cut k square both in numerator and denominator, and we have obtained the answer b square plus bd plus d square upon b square minus bd plus d square, which is equal to b square plus bd plus d square is to b square minus bd plus d square. Clear? So question number 12 is over. Now let us solve the next question, that is question number 13. Okay, now question number 13. In question number 13 we are given again a is to b as c is to d. So in the same manner we will proceed. Let a by b is equal to c by d is equals to k. Therefore we have a is equals to bk and c is equals to dk. Okay, now The first question is these values which you have to substitute. Okay. Number 1. Okay. A plus B upon C plus D is equal to 2A square plus 7B square, 2A square plus 7B square upon 2C square plus 7D square. Okay. Now let LHS is given A plus B upon C plus D. So now we can substitute the value. For A we can put BK, B as it is, and for C we can put DK plus D as it is. Take B common from numerator, bracket K plus 1 is left. Again D common in the denominator, K plus 1 is left, so we can reduce K plus 1. So B upon D is equals to B is to D. Clear? This is the left hand side. Now let us solve the right hand side. Okay, RHS is given to be 2A square plus 7B square. Two A square plus 7B square. This is square root of 2A square plus 7B square upon 2C square plus 7D square, 2C square plus 7D square. Okay. Again for A we will put BK. So 2 into BK the whole square plus 7 into B square upon 2 into DK the whole square plus 7 into D square. Okay, now 2B square K square plus 7B square, 2D square K square plus 7D square. Okay, now we can take B square common. Yes or no, both are in square root. Okay, so if you take B square common and take the root, then outside we can put B, and what is left inside, that is 2K square plus 7. Again from the denominator, if you take D square common, then square root of D square will be D. So square root of 2K square plus 7 is left. So now we can reduce this term, 2K square plus 7 in numerator and denominator. So we are left with B upon D, which is equals to B is to D, which is equal to LHS. Left hand side. Clear? Hence proved. Okay, now let me solve second, then third one I will leave for you, because in all we have to substitute the same values and simplify. Second one I am solving, then directly fourth one I will solve. Okay, now second of question number 13, that is MA square plus NC square upon MB square ND square is equal to square root of A raised to 4 plus C raised to 4 upon b raised to 4 plus d raised to 4. Okay, take left hand side. We have ma square plus nc square upon mb square plus nd square. Okay, here value of a is bk and value of c is dk, so let us substitute. So m into bk square plus n into dk square, denominator mb square plus nd square. Okay, so we have m into b square k square plus n into d square k square upon denominator is mb square plus nd square. Okay, from the numerator we can take k square common. Okay, so in the bracket we are left with mb square plus nd square, and denominator we have mb square plus nd square. So in numerator and denominator we have same bracket, we can reduce. Okay, so we are left with k square. Clear? Now let us simplify right hand side and bring k square. Okay, so what is right hand side? RHS, that is square root of a raised to 4 plus c raised to 4 upon b raised to 4 plus d raised to 4. Okay, let us put the values. A is bk, so bk raised to 4 plus c is dk, so dk raised to 4 upon b raised to 4 plus d raised to 4. Okay, so we have b raised to 4 k raised to 4 plus d raised to 4 k raised to 4 upon b raised to 4 plus d raised to 4. Okay, now from the numerator we can take k raised to 4 common. So when you take k raised to 4 outside the square root symbol, we will write k square. Okay, equal to, we have k square, square root, what is left? B raised to 4 plus d raised to 4, and in denominator we have square root of b raised to 4 plus d raised to 4. So these terms can be reduced. So we are left with k square, which is equals to left hand side. Hence proved. Clear? So similarly you can solve number 3. Just substitute bk for a and dk for c and simplify both LHS and RHS. You will get both the sides equal. Okay, now let me solve number 4 of 13. Okay, we are given a plus c the whole cube upon b plus d the whole cube is equal to a into a minus c the whole square, a into a minus c the whole square upon b into b minus d the whole square. Let us take left hand side LHS. a plus c the whole cube upon we have b plus d the whole cube. Okay, for a bk and for c we can put dk, so bk plus dk the whole cube, and denominator we have b plus d the whole cube. Okay, now from the numerator we can take k common. So when you take k common, since the bracket is cubed, k cube will come out. So we'll write in the numerator k cube into bracket what is left, b plus d. Yes or no? The whole cube upon again we have b plus d the whole cube. Okay, so we can reduce this bracket and we are left with k cube. Okay, now we'll take right hand side and substitute the values. Okay, so we have right hand side, that is a into a minus c the whole square upon b into b minus d the whole square. Okay, let us put for a bk. So bk into bk minus dk the whole square upon b into b minus d the whole square. Okay, from the bracket in the numerator we can take k common. Since the bracket is squared, k square will come out. So we have bk into k square. We are left with b minus d the whole square upon we have b into b minus d the whole square. Now we can reduce this b and the bracket, and we are left with k into k square, which is equals to k cube, which is equals to left hand side. Clear? So we have completed question number 13. Okay, now we will start question number 14. So let us begin question number 14. Okay, in question number 14 we are given x upon a is equals to y upon b. It is given that x upon a is equals to y upon b is equals to z upon c. Okay, we have to prove the following given 4 questions. Okay, so let x by a is equals to y by b is equals to z by c. We will consider some constant k. From the given ratios, all the 3 ratios are equal and each ratio is equal to k. Therefore x upon a is equals to k, y upon b is equals to k, and z upon c is also equal to k. Therefore x is equals to ak, y is equals to bk, and z is equal to ck. So we are going to substitute these values. For x ak, for y bk, and for z we will substitute ck. Okay, now let us begin from the first of question number 14. Okay, here it is given that x square plus y square plus z square, x square plus y square plus z square upon a square plus b square plus c square is equal to px plus qy plus rz. Okay, is equal to px plus qy px plus qy plus rz the whole square upon PA plus PB plus PA plus QB plus RC PA plus QB plus RC. Okay, and both numerator and denominator. Okay, by mistake. Yes. So we got over here. Now see. Yes. There is a complete bracket. Okay, this ratio is given inside the bracket and whole bracket is squared. Clear? So let us take left hand side LHS. Okay, LHS is x square plus y square plus z square upon we have a square plus b square plus c square. Value of x, we know that value of x is ak, so we have a into k the whole square. For y we have bk, so b into k the whole square, and value of z is ck, so c into k the whole square upon we have a square plus b square plus c square. Okay, numerator is a square k square plus b square k square plus c square k square upon we have a square plus b square plus c square. Okay, now take k square common from the numerator, so what is left in the bracket is square plus b square plus c square, and the denominator is also a square plus b square plus c square, so we can reduce the bracket. Okay, so LHS is equal to k square. Now similarly we will simplify RHS by substituting the values of x, y, z, and then we'll bring k square. Clear? So let us take now right hand side RHS. Okay, what is RHS? That is px plus qy plus rz. We have px plus qy plus rz upon pa plus qb, pa plus qb plus rc the whole square. Okay, now let us substitute the values. Value of x is ak, so p into ak plus q into bk plus pqr, r into ck. Okay, upon pa plus qb plus rc the whole square. Okay, now in the numerator we have k common, so take k common since the bracket is square, so when we take k outside the bracket we have to write k square, and in the bracket what is left, pk, sorry, it is pa or yes, pa plus qb plus rc upon again pa plus qb plus rc the whole square. Okay, so k square into 1 the whole square, because pa plus qb plus rc numerator and denominator we will cut, which is equal to k square, and which is equals to right hand side. Okay, so the first one of question number 14 we have completed. Now let us solve. second one. Okay. Second question of question number 14, x cube by a cube, x cube by a cube plus y cube by b cube plus z cube by c cube is equal to 3xyz upon ABC, 3xyz upon ABC. Now take left hand side LHS and put the values. Okay, we have LHS x cube upon a cube plus y cube upon b cube plus z cube upon c cube. Okay, value of x is ak. So numerator will be a cube k cube upon a cube plus again for y bk. So b cube k cube upon b cube, and for z ck. So c cube k cube upon c cube. We can reduce this a cube, b cube and c cube. So we are left with k cube plus k cube plus k cube is equals to 3k cube. Okay, now let us simplify RHS on the same page. Okay, we have right hand side is equals to 3xyz upon ABC. Let us substitute the value 3 into for x we have AK, into y is BK, into z is CK upon ABC. Okay, so the numerator can be written as 3 k into k cube into ABC upon ABC. So now we can reduce this ABC. Now we are left with 3k cube, which is equal to LHS. Hence we have proved that LHS is equal to RHS. Okay, now let us solve number 3. Okay, question number 14, third number. Okay, x cube upon a square plus we have x cube upon a square plus y cube upon b square, y cube upon b square plus z cube upon c square is equal to x plus y plus z, x plus y plus z the whole cube upon a plus b plus c the whole square. Okay, LHS x cube upon a square plus y cube upon b square plus z cube upon c square. Okay, value of x is ak. So we will write a cube k cube upon a square plus again for y bk. So b cube k cube upon b square, and for z ck. So c cube k cube upon c square Now reduce a cube upon a square will be a. So we have ak cube plus bk cube plus ck cube. Take k cube common, so we are left with k cube into bracket a plus b plus c. This is the left hand side. Now let us simplify right hand side. Okay, so RHS, that is x plus y plus z, x plus y plus z the whole cube, upon we have a plus b plus c the whole square. Okay, value of x is ak, for y bk, and for z ck. Okay, upon a plus b plus c the whole square, and numerator is cube. Now take k common, so when k is taken common, we have to write outside k cube because bracket cube is there, and in the bracket we are left with a plus b plus c the whole cube upon a plus b plus c the whole square. Now reducing the bracket, uh, using the laws of indices, you will get a plus b plus c, which is equals to LHS. Hence, we have proved that LHS is equal to RHS. So, in question number 14, we have solved the third one. Two more are left, which we are going to solve in the next video. I hope you have understood all the questions which we have solved today. If you have any doubts in any of the questions, you can get back to me. By that time, take care. Goodbye.